And welcome back, folks. We are continuing our work on debugging programs in the simulator. We are now into part 2. So, just recall where we left off from last time. There's an error with our multiply program. We tried testing using the step-through method to see if individual lines of code have an issue. However, all the individual lines of code are doing as they should, so we will need a new method besides tracing to determine the error in our program. So this method is going to be, we're going to look at debugging the loop with a breakpoint. So this is one good technique for discovering whether a loop is being executed too many times. So it's a +1 iteration loop. And the way to do that is to put a breakpoint at the branch instruction. That way you can pause once at the end of each iteration and check out the state of various registers and memory locations for more complicated programs. So let's set that breakpoint. So let's set this breakpoint in a different way than last time. So you get to see the breakpoints dialog box. So click on the little stop icon there, and you'll see this box come up right here. So if I bring up my simulator here, I'm going to go ahead and click on the breakpoints button here. If you click on the drop-down arrow next to the location field, you can see you have all sorts of choices. PCX, PCSR, IR, CC, and registers 0 through 7. So let's work on choosing that location. Basically, you can have the simulator pause when notice that any one of those registers or memory locations has the value that you specify. So if you want, you could set breakpoints to simulator pause when register 0 contains 00FF. You choose R0 for location, 00FF for value. Or when the condition codes have Z equals 0, so you choose CC for location, Z for value. Or when the memory location 4000 contains 1, 2, 3, 4, so you choose location 4000 and 1, 2, 3, 4 for value. In this case, you want to choose the program counter for your location. So remember, the program counter is part of our loop iterations here, and type 3203 in your value. So if we look at this, I'm going to choose program counter. I'm going to type 3203 in here, and I want to, of course, add that. So now you have two items listed breakpoints, both having to do with the program counter. Right. Now I do have this other one that's in here, this 3204, which was the one I made. You can see there's one over here at 3009. So that is just from the data set. So I could actually even probably remove some of these if I really wanted to. But I could just leave that in right now because this 3209 really doesn't affect me. But these are the two important ones right here. Okay. The simulator will pause whenever the program counter gets to the value 3203 or the value 3204. So click OK to close the window. So if you have extra breakpoints in here, you could just tell me here, like I did, click remove. These are the two that work. Remember, this is the one that has the halt command. This is the one that has the branch instruction. So let's go ahead and work on rerunning our program. So the first thing that we're going to want to do, so I'm just going to click OK, is I want to set the program counter to location 3200, and register 5 to 3 the same way we did earlier. So I'm going to come right up here and set that to 3200. I'm also going to come in here and set register 5 to 3. We're going to now click on Run Program, and almost immediately we should see this. Run Program, breakpoint encountered, and it's at 3203, which is right because we should have it stop there. Click OK, and you'll notice what has changed in your registers. So if we click OK, we can see then that the blue arrow and the program counter both point to line 3203 because that's where we're at. Register 4 is unchanged. It still contains 5. Register 5 has changed, contains the value 2. And register 2 has changed, it now has the value 5. Additionally, the condition codes have P equals 1. All right, that tells you that when you continue to run the program, the branch will be taken. Because remember, when it goes negative, that's when it's going to exit the branch. So let's go ahead and click Run Program again. And we're going to close the pop-up window, same as we did the last time, and look at our registers, particularly register 5 and 2. So let's just run it again. Counters the breakpoint. Now we've gone through the loop 2 times. So register 5 you'll see contains 1, and register 2 the decimal 10. The condition codes again have p equals 1, so you're going to do loop again when you continue to run the program. Sure enough, register 5 is 1, register 2 is 10. So if we click once more and click OK, register 5 now equals 0, and register 2 should equal 15. So I'm going to click once more. There's my breakpoint. Register 5 is 0, register 2 is 15. Since 3 times 5 equals 15, we know this is where we want the program to stop, because we just know that. But let's look at the condition codes. Z is 1. So if I look at my CC, it says that's Z. It's 1. It's not positive. It's 0. It should be negative, though, for the loop to stop. And our branch statement is written so that we'll branch when either Z or P is 1. So instead of stopping, we're going to end up taking that branch again and do an extra unwanted iteration of the loop. That's the bug, because remember, we got 20 instead of 15. So that right there is our bug in our program. This is an example of a logic error. All right, it was something written wrong with the code. It compiles fine, but there was something written wrong with the code. So let's work on fixing our program. So by changing the branch instruction to be taken when p equals 1, the loop will happen the correct number of times. So we don't want, when 0 is true, we want it to stop. We want to go 3, 2, 1, done. We don't want it to hit 0, because otherwise that's too many loops. So to prove yourself, you can add the program in LC3 edit and change the branch line to this. So let's go ahead and open up the LC3 edit. So here's my editor. And I want to change the branch line. And remember, this was the branch line here, 0, 0, 0. And notice it says 0, 1, 1 right now. All right, because remember, it's negative 0, positive. So I'm going to come in here and change that to negative is 0, 0 is 0, and positive still 1. All right, branch to location 321 if the result is positive. So we're going to take out that little comma there too. Let's go ahead and save. All right, so we save, convert over to object format, and load the new version into the simulator. Now, do note that you could just change the value in the simulator, but the issue with that is the next time we load our multiply program, the bug is still ultimately going to be in the program. It doesn't really fix the problem. It just kind of temporarily works it. And therefore, it's usually best to make kind of these more incremental changes when you're looking for more bugs. So sometimes one thing, if you fix it, could fix everything else, where if you start chasing everything, it could be a headache to try and remember every kind of change that you've made. So I'm more in favor of the incremental approach. So you fix one bug, let's go chase another one. So let's save this, and what we're going to do is let's reconvert that over. Remember, this is a binary. So I save that. All right, so now let's test to see if our program works. So we're going to reset the program counter once again and change register 5 to contain 3. All right, double click on the stop sign instead of 3202 to remove that breakpoint, then click run. Okay. So another way you can do this, of course, if you don't want to do all that, you can just come up here, reinitialize the machine, and then you can reload your multiply program, which we just saved. Both ways are fine. After closing the breakpoint pop-up, you see the beautiful long read value of decimal 15 and register 2. So let's go ahead and make sure we have our breakpoint in there, 3204. Run the program. Click OK. All right. If you notice, it did not give me the value I did, and it's because if you do it this way, and the reason why I wanted to show you that, if I reload my program, all right, here's my program. Put in my halt instruction. It's because I did not put my values in here. So you have to remember to put your values back in here for this program to work correctly. So there's 5. Here's 3. Go ahead and rerun that program. There's my breakpoint, and now it's got 15, which is what I ultimately wanted. So you have to remember to put those values in there. So congratulations, you've now successfully debugged your first program. And that concludes our notes for this time, folks.